Hey guys, and welcome to another one of my videos. So in this video, I kind of wanted to do something different. So in this video, we're going to be recreating one of my favorite games that I used to play when I was a kid, especially in class, which I wasn't supposed to, but it's called Cubefield. And the way it works is you just play as this little triangle, and you have to dodge and weave between these cubes, and when you hit one, the game ends and it restarts. So I'm going to be doing this in Unreal Engine, and then this isn't going to be a tutorial, it's just going to be a quick walkthrough of what I'm doing at a fast speed. So the first thing I'm doing here is just creating a new empty level because I don't need this desert level. And then the first thing I want to do is just start creating these cubes. So inside this world, I'm going to drag in some cubes just to kind of get a frame of reference of where we are. And we also want to create a character so that we have somebody to actually control going through the world. And as you can see, I've created a static mesh, a spring arm, and a camera. So the static mesh is going to be for the triangle itself, and the spring arm and the camera are obviously so we can see it and position the camera where we want. I also imported the starter content so I could get access to this triangle. And then I just rotate it so it matches like it does in the original game, where it's kind of tilted down at an angle. And then right here, I'm just adjusting the scale of it, trying to get it to look nice. And I also spend some time adjusting the camera, trying to get it to the correct location. The next thing I do is I begin setting up the game mode so that I can actually make use of my pawn. So I create the game mode, set my pawn, and I drag my pawn into the scene. And then from here, I add a light so we can actually see things. And again, just playing with the scale a little bit more to try to get it right. And I spend a little bit of time going back and forth on how far away the camera should be, how high it should be. I add a few more cubes just to get a better reference of what it should look like. And I spend some time trying to figure out where the player should start at. Eventually, I settle on something, and I drag in a player start at the location that I like, and this is essentially what it looks like. So the next thing I need to do is start working on being able to get the player to move through the level. So I just start out with a simple implementation where I take the player's current location and I add to it slightly a new position in front of it. And I create a speed variable so I can control how fast the player will move through the level. And I also multiply this by delta time, so it won't be dependent on your frame rate in any way. And I start out with 100, and as you can see, this is a little bit too slow. So I go back and try something a little bit faster, like 1,000. And I think I eventually settle on this. Or actually, maybe I just crank it up a little bit higher. And then again, I just continue to play with the scale and the spring arm. I did this throughout the video. I was constantly adjusting the size of everything and the spring arm to try to get it to look more close to the original game. The next thing I wanted to start working on was getting the cubes to spawn, because I didn't want to have to go in and place cubes throughout the entire map. I wanted the cubes to spawn randomly, but the important thing is that I wanted them to spawn in rows. So what I mean by that is I wanted each cube to be in a row so that you can't have cubes that are slightly misaligned. I wanted the cubes to be separated by 100 units between each cube. So I originally started doing this probably not the best way, where I was basically trying to calculate how much distance the player has traveled, and by that distance calculate how many rows should have spawned. And then I was going to loop over the rows, and you can actually see I stop right here because I'm kind of trying to think how I'm going to do this. Loop over the rows and spawned the correct number of rows. And this is something about game development that, at least for me, happens all the time, where I start down one implementation and I'll usually have to sit for 5 minutes trying to figure out what I'm going to do, and then I'll eventually start implementing it just to realize that there's a better way to do this. So as I'm going here, I'm trying to figure out how many rows should spawn. And so I'm just going to do a little print string here to figure out how many I can spawn. So you can see I have spawn, and I calculate this value, and eventually I will print it out here in a second. And like I said, printing out things is really useful. I use this all the time when I'm trying to debug stuff, because typically breakpoints can be kind of annoying when you're just trying to see what a value is. Sometimes it's easier just to go ahead and print it out. So right here, I'm basically trying to figure out how how far along the player is, and I wanted to add some sort of buffer so that the cubes don't start coming at you immediately. So what I do is I go ahead and I create a variable here called, I forget what I call it, I guess we'll find out in a second, Initialize Distance. So this is basically the distance before the cubes start spawning in. And so I want the rows to start at that distance. So let's say like 1,000 meters in front of you. So at 1,000 meters in front of you, that will be row 0. And then row 1 will be like 100 units behind that. And row 2 will be 200 units behind that. And so on and so forth. And that's so that the player will have a second to react when the game starts. And he won't just have cubes in his face right off the bat. So here I'm printing out the current row that the player is on. So you can see he actually starts on a negative row if you look at the top left. And so he starts at a negative row. And then once the game starts, once he gets past 0, that's when the rows will actually start spawning in. And then at this point, you can see I started deleting stuff because I realized it's probably going to be easier to do this a different way. Instead of trying to calculate how many rows have passed since the last frame, it's better to just calculate the current row that I'm on and remember the last row that I spawned. And let's say the last row I spawned was 12 and the current row that I'm up to is 15, then I'll just know that I need to spawn rows 12, 13, 14, and 15, right? And so eventually I switched to that method and it made things a lot simpler. Usually the first time you implement something, you tend to do it in a more complicated way. And then once you kind of figure out what it is you're exactly trying to do, it's kind of good to stop and reevaluate what you're doing. And you can usually come up with a much simpler approach to doing it. And it's much easier to read and it's usually more efficient and so on. So at this point I got the rows figured out. So now I made a handy little function here for actually spawning a row. So to start with, I just wanted to try spawning 1 cube per row just to make sure I got the distance right, because like I said before, I want them to be in equal distance apart from each other. And right here I'm just making a couple of macros to easily get the player's distance from the start and also get his location, because I wanted the cubes to spawn in front of the player, because the player can move to the left or to the right as much as he wants. So if the player just moves to the left, I want the cubes to start spawning to the left. And so that's why I'm using the player's location, and I'm just offsetting the X, which is the forward distance in front of him, by that amount. And then right here I'm just created a quick cube blueprint so I can actually have something to spawn. And then I'm just going to go ahead and test it here. So you can see once I get past that initial distance, cubes start spawning in at rows. You can see they're equally spawned apart from each other, and they're spawning in front of the player, which is exactly what I wanted. So now it's just a matter of taking these cubes and spawning more than one of them and spreading them out. So you can see I'm doing a random integer here, which is the number of cubes I want to spawn per row. So I said 0 to 10, and then I'm going to loop over those and spawn each one, but I don't want to spawn them all on top of each other. I want to spawn them left to right. So right here I'm just looking which way is left and right. I figure out, okay, it's the y-axis. So you can see I do -1,000, +1,000, and now they're spawning in a nice cluster around the player. And then of course I spend some time just playing with these numbers. So you can see I spread them out a little bit more. I actually noticed at this point that the cubes are spawning further and further in front of you as you go. And I just kind of mentally noted that as a bug, and I'm going to come back and fix it later, because I wanted to start working on the fact that the cubes don't get deleted. So I spent a while trying to figure out how I should do this in an effective way, because the cubes behind you don't need to stay anymore. I thought about a bunch of different options, but eventually I settled on this, which is adding a tick event inside the cube and setting the tick to happen only 1 second. So it only ticks every 1 second, and each second it will check if the cube is behind the player. So it's not super expensive. It's not like it's running every single frame. It's just running once a second per cube. And so the cube, you know, at some point once it gets behind you, we could probably even do much higher than 1 second, like 5 seconds, if you're worried about performance. But this way they just kind of delete in clumps as they get behind the player. And it was a very simple solution. It probably wasn't the most optimized solution, but simple solutions are sometimes better than optimized solutions. If you're already running at 500 FPS, what does it really matter? And frankly, I think this is pretty optimized anyways, so I wasn't super worried about it. And so there you saw that working. And then the next thing I wanted to do was I wanted to start working on allowing the player to move left and right. So I added a simple A key press here for A is left, and I was going to do D for right. And I switched it over to using a floating pawn movement because I wanted to add a sort of gliding effect. However, you can see here I'm having some issues. Eventually, long story later, I realized that the A key wasn't working because it wasn't detecting when you held it down because it was an action mapping and not an axis mapping. So I made an axis mapping and I hooked that up, and now it will actually get called every single frame that you're holding down the key. And so now when you press play and I run it here, you can see now I can move left and right, and it kind of slowly comes to a stop, and that's because of the floating point movement. One thing I noticed here as well is the shadows. So I turned off shadows on the cube because I just thought it looked better without having shadows casting onto the player. And I also tested right here, you can see I'm setting the max FPS. I'm just testing to make sure that nothing is dependent on the frame rate and that I'm using the delta time correctly. And I was. So the next thing I wanted to do is I wanted to work on the camera rotation, because if you remember from the original video, when you turn, the camera kind of tilts as well with it. So this is another example of when I kind of started down the wrong path. So initially I thought, okay, I'm going to rotate the camera itself, and I'm going to do it whenever you press the key down. So whatever the value of the axis is, so -1 if you're pressing A or +1 if you're pressing D, that will determine how much the camera rotates. And I was doing an interpolation to that so it'd be smooth. However, I'm just going to leave this in fast forward, because when I started doing that, bad things started to happen. You can see it really just got very disorienting very fast, and it did not look like the original video did. So I quickly realized that it should be the player that rotates and not the camera, because if the player rotates, the camera rotate with it. That also didn't work. So at this point I'm like, okay, I need to figure out a different way to do this, because clearly doing it based on the key press is not going to work. So I went back and looked at the video, and after just watching it for a second, I immediately realized, why don't I just rotate the camera based on how fast the player is moving to the left or to the right? Because that's essentially what's happening. If you're moving fast to the left, it's rotated far to the left. If you're moving fast to the right, it's rotated fast to the right. So with that new idea in mind, I took the code that I had for rotating the camera, and I tried to figure out how can I associate this with how fast the player is moving to the left or the right. So the first thing I did here is, again, I used another print string, and I just printed out the value of the velocity of the character when he's moving left and right. So you can see at the top left here, I have the velocity printing out. So when I move left, it goes to about -840, and when I go right, it goes to about +840. So I said, okay, I'll take this -800 to +800, and I'll map it to a camera rotation. So for example, when you're going -800 to the left, we'll map that to, let's say, a -20 degree rotation. And when you're going 800 to the right, we'll map that to a +20 rotation. So that's basically what I'm doing here. I'm just kind of trying to work through it in my head. And so here we go. So this is what it looks like finally. And you can see it nicely transitions back as I slow down. So it's basically just saying rotate the camera more the faster you start moving to the left. And then again, this is where I said, okay, I need to go back. I need to actually fix this issue, because you can see as I move, the cubes in front of me are actually spawning further and further and further away as I go. And so I went back to look at my spawn row function, and I realized that it's spawning them based on where the player is. So it's actually adding the player's location to the row's location, but the row location is already taking that into account. This is just me trying to debug it for a second and figure out what's going on. I eventually realized what's going on, and you can see right there, I fix it. However, now they're spawning way too close to the player, so I bump out the initial spawn distance to 5,000, and it looks a lot better. I also decreased the camera rotation because I realized it was a little bit too much and kind of was making me sick when I was playing it, so I decreased it from 20 to 10. So the next thing I started thinking about was, well, what happens if I just hold down the right key or the left key? Will the cubes still continue to spawn in front of me? So I really quickly ran it again and got into the middle of cubes and held down right, because I was worried that they wouldn't continue to spawn in front of me. And sure enough, since they're spawning so far in front, they don't spawn directly in front of me if I'm just holding down left and right. So to fix this, it's pretty simple. All I'm going to do is increase the range that they spawn in from the left to the right. So if I went from -3,000 to 3,000 to -10,000 to 10,000. And now you can see I run it again, and you can't even tell that they're spawning in front of me. And this is just an aerial view of what it looks like. So you can see they're spawning much further to my left and to my right. So even if I hold down left or right, I'm still always going to be inside of the cube field. And of course, they're spawning in front of me now, and they're getting deleted as they get behind me. I then decided to decrease the number of cubes per row because it felt like it was a little bit too much. And this felt a little bit closer to the original game. And then from here, I wanted to start adding some color. So I created a material, and I added a color parameter to it so that I could reuse this material for different cubes. And I took a screenshot of the game and just grabbed some hex values for the colors. The colors are just yellow, orange, and red. So I just grabbed each one of those and added it to the color palette in Unreal so I could easily reference them later. And then inside of my cube blueprint, I assigned that material to my cube. And then from here, I just wanted to make it so that each cube chose a random color, so either yellow, orange, or red. And for that, I created a dynamic material instance so I can modify that color parameter at runtime. And then I create a random integer between 0 and 2. And then I use that integer to figure out which color the cube should be. So now it's looking a little bit closer. However, we still have this ominous black background, and the player is still white. And I think in the original game, he's grayish. And so I changed the background color to better match the game. This took me a while to figure out, but eventually I got it pretty close using this exponential height fog and the sky atmosphere. I wanted to have a gray ground, or I think a white ground and a gray sky or something like that. No, gray ground and white sky, yeah, like this. You can see the background's a little bit blurry, so I wanted to try to get a sharper line since that's closer to how the game actually has it, like a horizon line. And I was able to do that using the fog. And now at this point I have the background looking pretty good and I have the cubes looking pretty good. So I created a instance of this material and I made it gray for the player. And then I set it to the player and made it a little bit darker because it was too gray. And there we go. So now I got the colors looking correct. So now I really need to add the collision. That's the next thing, because right now you can just go through the cubes without any consequences. So I immediately start looking into the collision presets. I switch the player to overlap with everything. I set the cubes to be triggers, so that way when the player hits them, they will trigger the overlap event. And then inside the cube, I override the overlap event. And inside my game mode, I make an in-game function. And so when the player hits a cube, I call in-game inside of the game mode. And so this way the game mode, which is sort of the brains of the operation, can figure out what it needs to do when the game ends. And then from here, we're later going to be adding code to reset the game and show like a game over widget and all that good stuff. But for now, what I want to do is just inside my player, I want to bind to when the game over event gets called. So in my game mode, I made an event dispatcher. When game over gets called, it alerts the player and it tells the player to set its tick to 0. So you can see when he hits something, the player's tick stops ticking. Thus, he stops moving because he's no longer ticking. And he kind of just hits something and stops moving. At this point, I just need to make a pop-up widget now to tell the player that the game has ended and give him the ability to restart the game if he wants. So I make a new widget, I add a little bit of background blur, and I kind of darken the background as well. And then I add text for to tell the player that the game is over. And this kind of takes a while. Sometimes widgets can take longer than actually programming things, which I've found. And then I also wanted to add a button, like I said. So I went ahead and added a button here, and then I just wanted to call it restart. And when it restarts, I just want to send the player back to the start of the game, and I want to reset his score, which we haven't done yet, but I'll do that in a second. And obviously I want to remove the widget from the screen. So once I have the button set up, I make a binding to it, and when the button gets pressed, I basically call this new function that I wrote inside the game mode called restart game. So inside of here, I reset the variables that need to get reset when the game is ending, and I also call it when the game starts, so that way when the game first starts, all this code will run as well. And I create a new event dispatcher for when the game starts, and I bind to it in my player, so that way I can re-enable tick and reset the player's location back to 000, which is where the game starts. And before I ran it, I actually realized that I need to delete the cubes as well, because when you restart the game, you obviously want to delete all the existing cubes. So I get all the actors and delete them. And then I think I was about to run it, but then I remembered that I'm not actually showing this game over widget. So when the game over ended, or when the game ends, I create the game over widget and I add it to the screen. And then when the game restarted, I simply remove it from the screen like so. And at this point, I think I'm ready to test it. Oh yeah, there's one more thing. Unreal wants to open for who knows why. We just need to call restart game whenever the player clicks the restart button. So now I press play and I run it, and I hit something, we should get the game over widget popping up, and there it is. But I quickly realized that I don't have a mouse, so I go back and I add code to switch the input mode to UI only and to show the cursor so that I can actually click the button. And then I do the opposite when the game starts. I make sure we're in game only, and I make sure that the cursor is hidden. So now if we play it, and we go and we hit a cube, we get the game over, and we can actually click it because our mouse is there. However, nothing is happening. So I do a little bit of investigation and quickly realize that I'm not resetting the actor's tick enabled, which is why he's not moving. So I just did that right there. And now our restart capability is working 100%, and I can replay the game as many times as I want. So the last thing I want to do here is just add a score. So I add a score widget. The score is basically just how far you've gone in the game. Right now there's really nothing else to it than that. In the original game there's nothing else to it, then it's basically just how far you've gone. And so I create a canvas panel, add some text to the top left of it, call it score. And then for the score, I simply just get the player's location, his Y location, and that is his score, because he starts at 0, so however far along he gets along, or sorry, not Y, along the x-axis, that's going to be his score. So you can see the score is going up pretty quickly right now. I thought it was a little bit too quick, so I simply just divided the distance by 100 and say, okay, this is going to be the score. So now we get a slightly slower incrementing value for the score. But as you notice, I did this inside the widget, which I realized is not a good idea. I should put this inside the game mode so that if somebody else wants to have access to the score, they can get it. So I just make a function inside the game mode, which does the exact same thing, and then I call it from the widget. And I change the text to black just to match the original game. And then the last thing I wanted to do is add the score to the game over screen so that when you lose the game, you can really clearly see what your score was. So I added another text to this canvas panel, anchored it to the top, and then I reused that handy function inside the construction script. For when the widget gets displayed to the screen, it just grabs the score from the game mode and it shows it on the screen. So this is me just showing that real quick that it's working. And if I hit something, there we go. And of course that worked, but now we have another bug where the player just infinitely goes to the left if you were holding down the left key. So to fix this, I just added some simple disable input code inside the game over, and then I re-enabled it inside the start game. And now I tested it again, and that bug is fixed. So now we get your score and we get the game over. So that's essentially it. There was more to the original game. It did have some other levels to it. If you guys are interested in seeing something like that, let me know. Like I said, this is the first time I did a video like this, so I don't know how well it's going to be received, or you guys like something like this. If you want to see me expand on this or maybe make another game, please let me know, because it was pretty fun to do and it definitely is something different. I realize it's not a tutorial, but I see a lot of videos out here like this, and a lot of people seem to like them, so I figured I would give it a try. If you guys enjoy it, let me know. Leave a like, consider subscribing. I also have a Patreon and some other info links in my YouTube channel if you guys want to support me there. I also have a Discord channel if you guys want to join. The link, all that stuff's in the description of the video. Thank you for watching the video, and I'll see you guys in the next one.